The objective of this video is to find the shaded area, the area in red, made by the intersection of four circles with equal radii of 3 units each, and the centers are at the point 40 on the right side, at the point 0, -4, the lower circle, and another one at -4, 0, which is the circle on the left, and the top circle at 0, 4. Now, the first thing to notice is that the shape is symmetric with respect to the x-axis, to the y-axis, and also to the origin. So, let's start. We first note that there are 4 points here that makes a square. We draw the square. We now write that the area we're looking for, the area in red with a small r, is equal to the area of the square, the blue square, minus 4 times small area. Now the small area, what is meant by the small area is one area of between the side of the square and the small arc. 4 times because we have got 4 of them in our shape. 1, 2, 3, 4. If S is the side of the square, AS is equal to S square. SA, the small area between the arc and the side of the square, will be calculated by subtracting the area of the triangle, starting from here, here, and here. So the green triangle. So we will say SA is equal to the area of the sector. The sector is this one here, minus the area of the triangle in green. So there are 3 areas to find. First, the area of the square whose side is S, here. Then the area of the triangle, and then the sector. Now let's start with S. So we need to find the side S, which is the distance between 2 points of intersection of one circle with 2 other circles. But because of the symmetry, we just need to find 1 point of intersection here, and let's call it A. Now, the point of intersection A, to find the coordinates of A, we need to find the intersection between this circle and this one here. So let's call it 1 and 2. The equation of circle 1 is given by x2 plus y minus 4 squared equal 3 squared. If you go back to the original shape given, the center of the circle is at 0, 4, and the radius is 3. Now, circle 2, the equation of circle 2 is given by x minus 4 squared plus y squared equal to 3 squared. Now, this circle, number 2, has a center at the point 40. Now, the intersection, we first expand 1 and 2. So 1, it can be written as x2 plus y2 minus 8y plus 16 equal 3 squared. Number 2, when expanded, it becomes x2 minus 8x plus 4 squared plus y squared equal 3 squared. Now we subtract the 2 equation to end up with minus 8y plus 8x equal to 0, which gives y equal to x. We substitute y by x in equation number 1. So x2 plus x instead of y because they are equal by this equation, equal 3 squared. Now we expand and simplify to end up with 2x2 minus 8x plus 7 equal to 0. And then we solve this quadratic equation to obtain two solutions, x1, 2 equal 2 plus or minus square root 2 over 2. So we found two solutions to the quadratic equation, and that's because there are 2 points of intersection, A and A dash. This point here, let's call it A dash. Now we are interested in the point A because this is the one that makes our square, and this is the point with the smaller x coordinate, so we can say that A has got the x coordinate 2 minus square root 2 over 2, and the y coordinate is equal to x coordinate, also 2 minus square root 2 over 2. Now let's look at the point of intersection of circle number 2 with the lower circle, this point here. Now we don't need to do any calculation because there is a certain symmetry. So point B will have the same coordinate as point A, 2 minus square root 2 over 2 because of the symmetry on the x-axis. And now the y of B will be minus 2 plus square root 2 over 2. B is a reflection of the point A on the x-axis. The length of side S is equal to, now A and B, they have got the same x coordinate, so it's easy to say that the S is equal to 4 minus square root 2. The next thing we are going to do is to find the angle of the sector. So we need to find this angle here, which we call alpha. Now we know that this is the, from here to here, this is the radius, which is equal to 3. Now we are going to say that the sine of alpha over 2, again there is symmetry, so we will deal only with alpha over 2 and then we multiply by 2. So the sine of alpha over 2 is equal to opposite side, which is half of S divided by the hypotenuse, which is 3. Alpha over 2 will be equal to the arc sine of half of S. We found S already, which is 4 minus square root 2 and divided by 3, and that gives alpha equal to arc sine 4 minus square root 2 over 6, approximately equal to 51.06 degrees. We now have all what we need to find the different areas. So if we go back at the beginning, we defined AS as being the area of the square. So AS will be equal to S square. We know S. We also talked about the area of the sector, which is equal to 1/2 alpha in radians r square. And we also need the area of the triangle AT, which is equal to 1/2 r square, the sine of alpha. So we continue. The area we are looking for, which we called at the beginning AR, is equal to the area of the square AS minus 4 times the small area, which is the difference between the area of the sector minus the area of the triangle. Now this will give S square minus 4. Now the area of the sector is 1/2 r square alpha in radians minus the area of the triangle. It's 1/2 r square sine alpha. We put the values in. Now here we have 4 minus square root 2 minus 4 times half r is equal to 3, alpha it's 51.06, we convert it into radians, minus 1/2, r is 3 again, 3 squared, and then sine alpha 51.06 in degrees. Now at the end, using the calculator, we will end up with the area we are looking for, approximately equal to 4.68 unit squared. Now in conclusion, although the problem seems to be quite simple at the beginning, we had to use quite few techniques related to algebra, analytical geometry, and geometry.